Hello and welcome. Today we'll be looking at Planck's quantum of action from the photoelectric effect, line separation by diffracting grating. So first of all, we set up our experiment. After setting up our experiment, we can now come and check our settings. We check our settings. We set the time constant to 0, amplification to 10 raised to the power 0. We set the electrometer to R equals to 10 raised to the power 13 ohms. Then we connect our voltmeter positive to the output of our amplifier like this. So we position the mercury lamp. This is our mercury lamp. This is our lens. This is our slits. And this is our photocell or diaphragm. You can call this diaphragm or photocell. And then as you can see, we have the opening there. So now the first thing we need to do is we can draw our table this way. Right? And then we have to locate the UV lines. Now we have to locate the UV lines. So the UV lines coming from the mercury bulb through the lens and then through the slits gives us this UV light, right? This is the spectrum that we'll be looking for, the UV line spectrum, right? So, right? So this is what we'll be measuring the voltage, the stable voltage for these UV lines, these colors. And then we find the respective wavelengths, and then we can use it to find the Planck's quantum action. So first of all, what we do is we position the arm, we shift this, right? We position the diaphragm, the opening of the diaphragm to the bulb, the diaphragm. We position the opening of the diaphragm to the UV lines. The first one, we make sure that the first UV line with the first color goes through the opening of the diaphragm. Then we can read the voltage. Then we'll read the voltage. So that's the first one. So this is the table. So the first color, we'll write the color. Then you can use the color that you have to write the wavelength, right? You can Google and check the wavelength for that particular color. Then write it. Then the voltage that you measured, or the voltage that appeared on the voltmeter, then you write it. So that's the first value. For the second one, we position the second color. So we can move the bench. We move the bench. See, we will be moving this. We'll be moving the optical bench. So we'll be moving this. We'll move this and then position the second color. Right? Position the second color at the opening of the diaphragm. At the opening of the diaphragm. Then we also record the corresponding voltage. Then we do for the next till we finish for all the spectrum we have here, right? So till we finish for all the spectrum we have here, right? For all the spectrum we have here, right? So we make sure the first color goes through the opening here. We record the corresponding voltage. The next color goes through the opening. We record the voltage. So we do that for all the colors. Now when you finish, we'll be plotting like how we did for the other. We'll be plotting the voltage. We'll be plotting the voltage. We'll plot the voltage against the frequency, hertz, right? We're plotting the voltage against the frequency. And then it's the same theory for the separation by refraction filters, the interference filters. It's the same theory for the one with the filters. So use the same theory we used for this. We use the same theory we used for this to be for this, because it's the same principle. The same principle. So when we plot this against this, we should get something like this. Thank you very much.